Have you ever had this happen? You've got a potted plant, it's looking a little sad, a little thirsty. So you grab your watering can, you give it a good long drink, but instead of soaking in, the water just beads up and runs right off the sides. Meanwhile, the soil in the middle, still bone dry. It is one of the most frustrating things for any gardener.
So, that's the big question we're tackling today. Why does this happen? It's almost like the soil is actively pushing away the very thing it needs to survive. And it's not just about being dry. This is a really fascinating scientific phenomenon happening right beneath our feet.
All right, here's our roadmap. We're going to break down why your soil might be hating water. We'll dive into the science, figure out what causes it, look at the big problems it creates, and of course, what we can do to fix it. Let's jump in.
Okay, first up, what does it really mean when soil hates water? Let's pull back the curtain on this hidden condition. And now for the science. It's time to zoom way in and take a microscopic look at the physics of what's actually going on. So the official term for this is soil hydrophobicity. And here's the key. This is not just a lack of water. It's a real physical and chemical change where soil particles get coated in these waxy, non-polar compounds. The best way to think about it is that each grain of sand has put on its own tiny, invisible raincoat. Now this is where it gets really interesting. In your normal, happy, wettable soil, the force of adhesion is strong. That means water molecules love to stick to the soil particles. But in repellent soil, cohesion wins out. The water molecules would much rather stick to each other, forming those little beads and droplets you see. And it all comes down to something called the contact angle. If that angle is over 90 degrees, congratulations, you've got hydrophobic soil.
You know, not all soils are created equal when it comes to this problem. Coarse, sandy soils are way more likely to become hydrophobic. And why is that? Well, it's all about surface area. Sand particles are relatively big, so they have a low surface area. It really doesn't take much of that waxy coating to completely cover them. Clay, on the other hand, is made of tiny, tiny particles with a massive combined surface area, so it takes a whole lot more of that waxy stuff to cause the same issue.
So the obvious next question is, where on earth does all this waxy stuff even come from? Let's take a look at nature's main triggers. We're going to focus on three main culprits. The first one is pretty dramatic and destructive: intense wildfires. The second is biological. It's the hidden work of fungi under the ground. And the third is a little bit of a paradox, and it involves something most of us have in our gardens: peat moss. The way fires do this is just wild. An intense fire doesn't just burn what's on the surface, it basically cooks the ground, turning all the waxy resins in plants into a gas. This hot gas gets forced down into the cooler soil below, where it then cools, condenses, and solidifies, creating this distinct, waterproof layer just under the ash. And then you have the peat moss paradox. When it's damp, peat moss is amazing. It's like a sponge, holding up to 14 times its own weight in water. But, and this is a big but, if you let it dry out completely, its whole cellular structure collapses. Those waxy residues get super concentrated, and it becomes incredibly water repellent. This is exactly why the water runs right off your potted plants. The peat moss in the potting mix has gone hydrophobic. Okay, so this is so much more than just a gardening problem. The large-scale consequences are so serious that scientists actually have a name for it. They call it the tin roof effect. And this quote just captures it perfectly. The soil, now completely sealed by that waxy layer, starts to behave just like a metal roof in a rainstorm. The water hits it and has absolutely nowhere to go. It just can't get in. And the consequences of this are severe, especially after a wildfire. The rainwater just sheets across the surface, setting off a whole cascade of disasters. First, you get massive erosion. All that precious, fertile topsoil just gets washed away. Then, all that runoff overwhelms streams and rivers, leading to dangerous flash floods. All that sediment pollutes our downstream water sources. And maybe worst of all, without any water getting into the soil, the land just can't recover. Plants can't regrow, and the ground becomes barren. To give you an idea of just how bad this can be, scientists have a test for it. And in extreme cases, a single drop of water can sit on the surface of the soil for over 6 hours before it finally soaks in. 6 hours! That's how powerful and complete this water-repellent barrier can be. So the problem is pretty clear, but what can we actually do about it? Well, in our final section, we're going to talk about hacking the hydration. The secret weapon here is a type of chemical called a surfactant, or what you might know as a wetting agent. The best way to think of them as tiny molecular diplomats. They have one end, a tail, that loves the waxy coating on the soil, and another end, a head, that loves water. So they literally grab onto both and force them to play nice. Now, not all surfactants are the same. For your garden, you definitely want to use ones that are safe for plants. The ones to look for are non-ionic types, or even better, biosurfactants, which are made from plants like yucca. The ones you really want to stay away from are the cationic surfactants. They can be really harmful to your plant's roots.
Okay, for that potted plant we talked about at the beginning, here's your emergency rescue mission. The absolute best way to rehydrate it is to just submerge the entire pot in a bucket of water. You'll see all these air bubbles rushing out as the water forces its way into those dry pockets. Just wait until the bubbles stop. Once they do, you know the soil is fully soaked. Then just take it out and let it drain completely.
And if you'd rather go with a more natural DIY approach, this is a fantastic recipe. You can actually make your own wetting agent using agar-agar, which is just a seaweed extract. You make a paste, dilute it in water, and then apply it to your garden beds. It's totally biodegradable and works for about 3 weeks. But here's the really crucial point. Wetting agents are a great quick fix, but the real long-term solution is all about building healthy soil. When you add organic matter like compost, you're introducing a whole universe of microbes, including wax-eating microbes that will naturally break down those repellent coatings over time and bring your soil back to life.
All right, let's do a super quick recap. Soil hydrophobicity is a physical condition caused by a waxy coating. The main triggers are big ones: wildfires, certain fungi, and dried out stuff like peat moss. This leads to the dangerous tin roof effect. And while surfactants are a great tool for a quick fix, the ultimate goal is always to foster a healthy, living soil.
So I'll just leave you with this one thought. The next time you're out in your garden and you see water beating up on the soil, you'll know exactly what's going on. And you can ask yourself a new question. Is my soil actually thirsty, or has it become repellent? Knowing the difference is the very first step to bringing it back to health.